Okay, welcome everybody. Excited to have everybody on hand here with us today. Excited to present you today with SDS2, STRUMIS, and EMI, kind of a little case study here on those products, along with Brion Hardin Construction with us, who's going to kind of give us a little bit of a rundown, a little bit of a case study, if you will, kind of on the success that they're having with the three different solutions combined together, what they're doing to have success. So should be a great presentation today. I'm excited about it. So let's hop into introductions here. So who do we have with us today? So my name is David Zabka. A lot of people probably know me from previous SDS2 webinars and that. So I'm currently the solutions engineer here with SDS2. I've been with SDS2 for about 16 years, doing everything from support, little management, sales, and now I'm the kind of the technical person here for our sales staff to help out with the technical side on our sales staff. So, Joe, I'll kind of turn it over to you if you want to give us a little bit about yourself, why you're here.
Sure. Joe Maxwell with Brion Hardin Construction, Senior Project Manager. Oversee estimating, production control, programming, a little bit of problem solving. Been with the company for 19 years and been in the steel industry for 30 years. So kind of seen it come from pencil to computer.
Yeah. So you've been through a few transitions and you've seen a thing or two over the 30 years, yeah. I'm sure. Yep, very good. And then we have Chris Eaton here with STRUMIS. Chris, you want to give us a little bit about yourself?
Thanks, David. I'm Chris Eaton. I'm the product manager at STRUMIS, based in the UK. I oversee the development of the product, liaise with customers, other software providers, machine manufacturers, just to make sure we're constantly improving the product. I've also been in the steel industry for quite a long time, almost 20 years now. The first 10 of that being on the practical side, started off in steel erection, inventory management, purchasing, and lastly, production management. All that was using STRUMIS as a customer. Then I joined the STRUMIS implementation team, trained customers worldwide, and then moved on to manage the product as a whole.
Okay, very good. Thank you. And finally, we have EMI, Aaron, and I'm going to let you pronounce your last name so I don't butcher it.
Yeah, I'll take that. It's pretty French. So Aaron Ledoux from over at EMI. I guess I'm the greenhorn of the bunch. I'm only 4 years into the steel industry here. So I'm one of the senior engineers at EMI, so I work on some of the machine R&D, also part of the tech support team over here. So when customers have issues with their machines or questions, I get to field those and answer those, get them sorted out and back on their way. And then my other main responsibility here is I do a lot of the machine trainings. So, somebody buys a new machine, we go out, we show them how to use it. That's a big chunk of what I do here as well. So.
Okay, very good. So we know who everybody is. A little bit about the content today, what we'll be talking about. So we've already got the introductions. We'll tell you a little bit about STRUMIS, a little bit about EMI, Brion Hardin Construction, and then we'll talk through the integration of SDS2, STRUMIS, and EMI. I'll show you what some of that looks like in SDS2 then at the end before we get to some Q&A that anybody has. So we'll start off here, hand it back over to Chris for a little bit about STRUMIS.
Yeah, so just STRUMIS, what it is, it's an all-in-one software solution for steel fabrication industry and related industries. We designed it with efficiency in mind in general. We try to streamline all the fab shop processes from end to end, reduce waste, reduce costs, and also maximize productivity. At STRUMIS, we believe in the power of a complete solution, so tying everything together. STRUMIS is really comprehensive software. It manages all the details of a project at any stage. That could be estimating, project management, document control, production, and then we're control of the inventory and purchasing as well. So we believe that STRUMIS is like the backbone of a fab shop. It sits there just kind of taking all that data in from various different sources. And it has to do everything that our customers do. So we have to know their workflows. Our team of implementation staff, they customize STRUMIS to replicate our customers' workflows. And we also integrate with accounting and ERP systems to have like a digital environment or a digital transformation of a business. We call ourselves a management information system, and the aim is to provide visibility of project data, statuses anywhere in the fab shop, job site. We also provide integration using a bi-directional sync with popular CAD systems, SDS2 and Tekla. We'll see more of that later on today. And Joe will show us how we can do project status updates when we link SDS2 to STRUMIS. So not only do we bring data into our software, we also send the data back out to the source. We also work with Advanced Steel, SolidWorks, Inventor, among others, and we connect to workshop machines as well, and we can output native machine-specific formats that allow us to get status updates from machines to push through production statuses as well in an automated way. We're also aware of, in today's connected world, how important mobile technologies are. So we want people to be able to see that important business data when they're at the office as well. So we have a new web browser product where you can get access to things like dashboards and receiving material, to name a few. We've also got a barcoding application as well, which Joe will also speak about today, that they're using in their shop at Brion Hardin. So our purpose is to make shops more efficient and more profitable. We all know things like material prices are one of the biggest challenges that everybody's facing at the moment. So system like STRUMIS in general is designed to make more efficient material usage, reduce waste, reduce costs, be able to get a cheaper product for the customer, and also for our customers as well. So yeah, just to sign off, I suppose, why do we think STRUMIS works so well? It's industry people making software for industry people and understanding what customers' wants and needs are, and we work with them to provide that solution.
Okay, very good. Thank you, Chris. That's a great overview, good rundown of STRUMIS there. And Aaron, you're up next here with EMI. Give us a little bit of information, a little bit about EMI, what you guys do there.
Sure thing. And first off, Dave, I just want to say thanks for putting this together, you and the SDS2 team. It's a great opportunity for us. So as the slide says, EMI was started in 1996 by a guy named Todd Ferentz. He's still the owner and operator still, but sadly for him, but luckily for you guys, he was pulled away from the presentation today, so I'll be filling in his place. Again, we kind of went over this, but my name's Aaron Ledoux. I'm one of the head engineers here. I've been here for 4 years. I love just about every day I get to come here, but don't tell Todd or Janelle. That way they'll keep paying me. Over my last 4 years at EMI, I've realized that there's kind of 6 pillars of what we do that set us apart from some of the other machine manufacturers and people in our industry. The first one is quality. Our machines are designed to not stop until your job is done. Support. At EMI, we understand that our customers are what allows us to come to work every day. So we should keep them satisfied and happy and keep coming back for more. Creativity. We believe that if you can dream it and draw it, we can get it cut for you. We want to be able to open up those doors for people to fabricate whatever they can think of. Speed and efficiency. We combine 3 fabrication processes into one, which drastically reduces time and allows you to get from stick to parts a lot quicker. Precision. Production floors are going to go from measuring their parts with a tape measure, marking them with a crayon and cutting with an oxyacetylene torch, to using CNC equipment in order to get accurate and fast parts from our machines. And then ease of use. So we believe that the machine should be simple enough to operate, where somebody can just come in, quickly learn what they're doing, and be off and running. So I'm quickly just going to delve into kind of some anecdotes that I think kind of highlight how we exemplify those pillars and what we do over at EMI. So we have a machine silo of 4 machines, and this is for quality and durability. But those machines are robust enough to run whatever you need as long as you need it. We work with a company up in Rochester, New York called Ideal Manufacturing. They make skyscraper piles. I don't know if any of you guys have ever seen a skyscraper pile, but it's a 3.5-inch piece of pipe with 300 wall. Basically, it's about 12 feet long. It gets a corkscrew welded to the end of it. They drive it into the ground at the bottom of the skyscrapers, and they build the buildings off of those. So this company, they run about 29 bundles of this stuff a day. So now before you go saying, holy cow, they do run like 3 shifts. So they've got about 24 hours to do it, but it equates to about 464 sticks, about 9,000 plus feet. So the machines will produce what you need to, and they're not going to stop until your job's done. The next is speed and efficiency. So our machines bring production levels up by crazy amounts. You're not just cutting to length anymore, then taking it to a coper, then going to the fitting table, seeing if it fits. Oh no, it doesn't fit. You take it back to the coper. Oh no, that doesn't fit anymore because now the part's too short. All right, now we got to go recut it. We say no more coping, no more like checking to fit. We want you to be able to just go right to the machine, tell it what you need, and expect it to come out perfect the first time. The machine works on the inner geometry of our parts. So what that means is no more of that nasty weld or grinding either. So you're going to see on our parts here, we got some samples there. You'll see that weld reveal. That's going to allow your fitter to just walk right up, lay his bead right in there, and it's going to run into that groove. So you're going to be cutting down on the amount of time that he's sitting there grinding that weld away. Just overall increases your productivity through the shop. Another thing that we see is they increase their efficiency through utilizing a lot of the kind of smaller special features that we've built into our Peacemaker software. One of those is our triad joint. So back in the day, you would have to cut maybe 2 parts and cope them together, and then cut the third part to come in here and bisect that angle to make kind of your corner for a post. Now they're just clicking one checkbox in their Peacemaker program, and that's going to come right out of the machine. So you cut 3 of them, and you've got your nice 90-degree corner post. The next one we see is people doing automatic picket holes. So what we do is they'll put square round features down the length of their pipe. Now instead of having their fitter come back with a tape measure and a square to rest the picket on, they can just slide them right in, slide them in the top, and just weld around that nice little reveal there, which allows it to have some space to go as well. The last thing is kind of new in development, but it's something we'll brag about here. We call it super joint. So what it is instead of coping to the outside of the material, now what we do is we cut a notch on the inside of it that allows your mid rails to slide up right inside of it like that. Again, it gives you a nice little place to lay your bead of weld, not as much grinding. And then on top of that, you got perfectly open galvanized joints there. So you're not having to pop in weep holes and fill them. It's all internally vented. Then there's the precision. There's not a ton of points in making a CNC machine if it's not going to be precise. You want to be able to tell the machine what you need and get it right then and there. Industry margins in the fabrication world are pretty tight. So, a couple nickels and dimes between a major profit or a major loss. So we want you guys to not have to worry about, hey, how many times we're going to have to remake these parts. We just want you to be able to move on from them. So we use a closed loop servo motor system that's been proven with some tests on a CMM machine to have your positional range from plus or minus a 16th and your feature tolerance from plus or minus a 32nd. So again, you're going from measure it with that tape, mark it with the crayon, cut it with the torch, to you're within fractions of a millimeter when you go to fit stuff up. Lastly, we've got ease of use. So I get the benefit of being the EMI employee that gets to go out and see a lot of these machines in use in the field. And I just want to brag a little bit about the fact that within the first hour of training, this is what we usually cut. All right, so the machine's sitting on your floor for an hour. You've already spit out the first flat handrail from it. Within the next hour, you'll end up getting yourself a sloped handrail. And by the time that your guys finish cutting or eating lunch, we're cutting production parts. They're going to the weld benches to get fit up, and everybody's happy. Most of the training then kind of just devolves into how to best utilize the software. What are your niche case scenarios that you want to cover so that you can get your parts out to the machine, cut the way you need them to. Yeah. I did realize just now I forgot about our creativity part of the program, so sorry about that. But the machines are really cool. It never ceases to amaze me what we answer the phone and have customers ask in terms of, hey, could that machine do this? So we just finished up a project working with a customer out in San Diego. If you Google the Pepper Canyon Amphitheater, they cut all the horizontal bracing for that structure out of 5-inch pipe with copes to like 10-inch pipe. It's nothing that they could have easily done on their typical bandsaw or other setup. It's some pretty crazy copes going on there to get that stuff to fit up. Next, there was a local artist named Zach Oxman. You can look him up on Instagram. He made a pavilion for a customer down in Charlotte, North Carolina. It is like a canopy thing that's shaped like a lotus flower. You can imagine artist, lotus flower, not typically looking to make things easy for fabricators to put together. So he reached out to us over at EMI and said, hey, I've got some really weird end geometry on these parts. I heard you guys are great at cutting up pipe. Can you help me out here? So we cut about 60 braces for that project that he was able to put all together. So again, if you can dream it, we can make it work. We're doing stuff for propulsion launch pads in the aerospace industry. One of our customers is one of the premier East Coast drag racer chassis builders. So it's not just steel in the fabrication industry that we deal with. We kind of can open up to anything. So hopefully that gives everybody a sense of kind of who we are as a company, what we stand for, and what we do. Thanks for taking the time to tune in. Not just to me, Blab, but the rest of the presenters here. I hope you guys have a great day.
All right, very good. Thank you, Aaron. That's a great rundown. I'm really excited that we've been working with EMI here, SDS2 and EMI kind of pairing up here, working on our integration together with you guys. There's some good stuff, really going to change the way that people start to assemble their handrails and such, I think, once it catches on with, especially with the notch outs for the pickets and the way the rails come together and that. So pretty cool stuff. I'm excited about it. So next up, we've got Brion Hardin Construction. And Joe, you want to kind of take over here, give us a little intro to Brion Hardin Construction, and then we'll hop into kind of your case study and how you're doing all this stuff and integrating everybody together here.
Sure. So Brion Hardin Construction started in 1995, specializing industrial construction, ASME code vessel fabrication, process piping, and then in time we've gotten into structural steel fabrication and erection. We've got crane rentals, and then we also do machinery rigging and installs. So we see a good mix of requirements from the fabrication side in the shop to support multiple facets of the company. So So we may be making shim packs and pipe flanges to get them onto a job site to support an install or even a demo or a modification at a refinery while we're running structural fabrication in the shop to go to a new core facility or a new commercial building here in town. So we've got a pretty good mix of requirements. And one of the things that we tried to do was bring in some sort of system to tie all this together. And we did a lot of research in time, and ultimately we chose to go with STRUMIS. And with that, we're able, kind of seeing that photo there, we've got our laydown yard in the back as far as different scrap materials or leftover materials. So we've got inventory tags on all that material out there. So we know what it is, what job it was brought in, and the beauty of it is the guys can go out there in the yard, they can sort through it, they can find a tag number, they can scan it with a mobile app, or they can call up here to the office and ask us, and we can tell them what the material is, if we, what the grade of material is, what the length should be, or the physical size of a plate drop that's out there. And through that process, we have probably cut our scrap probably by about 65 to 70% as far as what we've been able to take out of the yard and bring it through. Sometimes we may blast the material, get the surface rust off of it, then run it through the fabrication process as if we brought in a new piece of material, because we can find that heat number on it. And we all know that in time, the heat numbers wash off or rust up. You lose that. Tags we use, we get about a 3-year life expectancy out of a tag for direct sunlight and weather. So that's really helped us control inventory. So when we brought STRUMIS in, brought in to get us from the 3D model that SDS2 creates for us to get us to production with the ability to use the estimating features in it, the purchasing features, production control, and then, of course, the barcode tracking. And to enhance the barcode tracking, which I know we're going to touch on later, the status updates. That has been a very big, helpful process for us in communicating with our customers that are multi-state away from us. Some of the examples we're going to show here later on, our customers in Washington State. We're in Tuscaloosa, Alabama. We've got engineers and other client reps spread across the U.S. So we use the BSWX input, we use the barcode tracking, and brought it all together. So when we get to those slides later on, we'll be able to recap on that. You jump to the next slide, would kind of give you a little idea of the shop. So We've got laser process in-house, plate drilling and cutting in-house, standard oxy-fuel, burn table, angle line, drill line. And one of the components that we were missing was the ability to efficiently produce handrail. And we had come through the shop in time and integrated STRUMIS in multiple phases. And we started with just standard production control. And then actually, I take that back. We started with inventory control because inventory was something easy to put into the system. From there, we went to light purchasing and material receiving, heat number tracking, and then we worked our way into production control and set some very simple status stop points for production control. We do like saw cut, fit, weld, and then we'd say, okay, hey, and in time we added additional checkpoints to the system. And one of the beauties of STRUMIS is we can tailor those checkpoints to the individual project. And set the same status points within SDS2, so that when we get to them, we get that communication between the two software packages. So the screenshot there on the left, that's basically the detail side, where the production side's on the other side, on the right-hand side where you see the drill line there. So we're kind of splitting the two halves, try to bring all the material to one at that fit point. So a little bit of reference there from the shop. So if you grab the next slide. So here, this is just basically a simple estimate timing report after we've done manual takeoff of material and applied process times that we've stored within STRUMIS to each of the different categories that we're producing of material. And with that, it gives us approximate number of man hours, what we've got for rates on that, and then what that theoretical cost should be. Then of course, we look at additional factors that go beyond the simple takeoff, say the complexity of welds, if there's moment welds in there, different things like that. But we use this as our baseline, because ultimately at that point, we're gathering our material. So go ahead and jump one more.
Are you, can I just ask a question? A couple of questions
Sure.
here. So you're using STRUMIS for your estimates as well, correct?
Yes.
Yep. And so that's all pretty much done through STRUMIS. So using kind of old school, your labor codes and shop codes to figure out some of those weld preps and stuff, and then that's all stored in STRUMIS, and they kind of calculate that within there through your estimate. Okay. Is this this report then is straight from STRUMIS, just out of the box report for you?
Yeah, this is a project that we did about 6 weeks ago.
Okay.
It's in 727 there. So this material here actually went out to Houston, Texas, for a customer of ours that had asked us to step in and help them produce the material. So we took it, ran it through the system, got a quick time, see if we could stop our commercial production work that we were doing, slide in this project for a customer. So we gather these man hours based on what it's going to tell us, what it tells us it's going to take to go through the machines. Is that
okay? Yeah.
In order to run something through, we got to stop one to produce, for another customer. So we use that as one of the tools and features within STRUMIS, and then it also has, STRUMIS has the ability to show us the backlog that we have assigned to the machines also. So we can look at that and see where production control is as far as going through those machines.
Very good, very good. Now we're on to a little bit of the processing needs here with what led you to implement the EMI machine, correct?
Yeah. So
on this slide here.
Yeah. What we do is we create a cutting plan list, shows the shop based on the cut plans that are produced, which machine they're going to be processed on. So in this, these components here are actually structural, but we assign the cut list to a machine. And we do the same thing when we use the EMI EL squared coper for both round material, square material, and angle shaped material. As we figured out how to run angle, odd leg size angle on the machine. And in addition to that, what we have found that on our angle line, we can't produce long slots. And we've been run into a condition where we need 1 7/8" slots. Can't punch that because that's larger than the punch body. But we can put it into the EMI and burn that slot in there, treat it as such under a cut condition. Aaron's helped us out numerous times on the phone where I've called him and said, I got a problem. And he's like, here, let's tweak a setting and get you squared away. So we've been able to step outside the box for some of the shapes that we've had to cut for different projects over time with the EMI. So.
Good job, Aaron. Way to good support there.
Yeah, that's what we're here for.
What, next slide here, looks like we got some barcoding, a lot going on here. Tell us a little bit about this here and the implementation then.
All right, so like I said, we put STRUMIS into project control back in 2019, and we started with active inventory and heat numbers that we could gather, data logging with that. So up in the top right-hand corner, you see a screenshot of a material traceability report where we've purchased new material or it's come out of inventory and been used for a project, so we can trace it back to its origin as far as when we brought it into our system. There's a copy of a cut list up there in the top left-hand corner I think that was for the drill line. Basically showing what size material is coming in, that material length, and then how it's going to, what parts are allocated to be produced from that. From there, once those parts are cut, you see 3 examples of a tag, and one is the yard ID 478. That's just an inventory control tag. So back to when I was talking about material that's stored outside or stored in the building, that's for our remnant tracking. So we use that on a regular basis, and the guys would call us and ask, you know, hey, is number 478 used for something? Or on that cut plan list that was on the page previous, we would tell them to use yard ID 478 and already have that drop assigned to that project. So they would know to look through inventory to bring that material into production. The tag that's right there in the middle of the page, that's a production control tag. That's a 2x3 decal that we use. That's a high-tack adhesive. That's a tag that's we use for either plain material or painted material. And for example, it has our job number, has a customer reference on it, has the part number, has a prime code, which is the SSP for standard shop primer. It has a 2000 for the sequence. Field Express is the verbal reference for the customer. The item shape, the tonnage weight, the quantity, and then the work order number that it's tracked through within STRUMIS. So we assign that after it's been fit. So our first checkpoint is saw complete, material fit. When the QC inspector says it's fit correct, we apply that tag to top flange left end, adjacent to the part number that's engraved into the beam or to the column. The tag that's in the bottom right, that tag is a 4x3, and in there, when we get into multi-coat or complex finishes, we actually put in to the painter what the surface prep is, and then each of the coats of paint required in the manufacturer, the number of mils for each of those coatings. So one of the big things that we were looking at, going back to looking at an MRP solution, is we wanted an all-in-one package, as Chris had mentioned earlier. So that was to get it from estimating through production control and ultimately through the barcode tracking, because for us, working with other fabricators, working with our customer base, if you have drawing revisions, we can tell them, no, it doesn't affect anything, or immediately, yes, it does. Because through the mobility app, I can be in a meeting with a laptop, with my cell phone, and I can see what's going on in the shop because we've got that connectivity. So we've brought the shop to the field in one aspect of being able to tell them exactly where we're at in a project and what the status of the parts is. So one of the big advantages for us is the built-in barcoding. And we're not relying on a third-party system. We're not having to translate, load information or output information to it, and then bring it back in and verify that it's being read correctly. It's not intertwined with another project because it's got a similar part number. With this, we've not had any issue. We just use some simple tablets and run the mobility app, and we've had excellent luck with it since we put it in. So.
Okay. Very good. Very good. So a couple things I'll point out here. So you did mention the barcoding. That's a built-in deal into STRUMIS, so no additional third parties or any third-party type of stuff there that you need for the barcoding. I will also point out, in order for that all to work, I know a lot of fabricators are still, kind of stuck on the old KISS files, transferring information from SDS2 to STRUMIS. Barcoding, things like that, is not possible with the KISS files. There's just not enough information and unique identifying numbers for the different parts and materials within that KISS file for the barcoding to track everything properly. So you do need to use the BSWX file format that SDS2 outputs. In order to do that, we have a plug-in on our SDS2 toolbox from our website that you get that will produce that file necessary for that. So just a couple things to point out there on that front. And then I think we've got this model here, and we'll see this model here within SDS2 here in a bit, but a couple screenshots. This is also that we kind of saw that in one of those screenshots of your shop here earlier.
Yes.
But I believe is this kind of the first project where you had everything integrated and brought everything together then?
So this project here, we had worked very closely with STRUMIS and SDS2 to integrate the live tracking through the BSWX model and with the barcode tracking of everything as far as all the components produced. And it wasn't your standard structural project, and we didn't want to have engraved piece marks on all the submaterial, because each of the 14 modules has close to 400 pieces of infill inside them once you have the tube steel frame. So we went back and worked with SDS2 to get the tracking feature down to submaterial level in addition to main member level. So we did a little bit of collaboration with Brandon there in your office, David, to get that put together. Chris and his team were great. Our outside detailer support was great. Our IT group, to get us all integrated as one so that we can use these color code status updates, so that as the material was received in, that lot was placed into STRUMIS to where we knew it was in. We had the heat numbers. We went into production, and every time we saw cut a part, we put a 1x4 tag on it. Simple tag, material length, part number, barcode. And those are low tack tags. And as far as adhesive, we put those on all the parts, so we would have just pallets of parts that we knew, both plate, tube steel. And when we built these module frames and started the infill process, every time that we put one of these in, we scanned the barcode. It would fit, tacked in place, it was verified. And then when it went to weld, we had a team of welders. So we tracked everything and got to the point where we would have these conference calls with these customers spread out across the U.S. First thing they asked for, can we get a screenshot? They wanted to see the 3D model. They didn't care about percentages. They just wanted to see the 3D model. They didn't have the luxury of coming to the shop and looking at the project each week. So we used the collaboration between the two systems to bring it together. And it helped us grow as a company. And it set us apart with our customers for what we can bring to them because of how we've integrated the barcode to the production control. And we were able to set numerous statuses. We set 6 or 7 different color codes, primarily through the system to give us some generic updates, but yet at any point we could go back and run the data to tell us exactly what day and time, who the operator was, who saw cut the part, who was in charge of QC for the fit up, which welding operator made the welds, and then of course who painted it, what day it was loaded, and then when we'd go to shipping, we already had the bill of lading because we could run the barcode. It'd give us the bill of lading and the shipping weight automatically. So at that point, it tied everything together. All of the rails that you see in these 2 screenshots, we produced all of those rails manually. We saw cut the part to length. We ran it through a coper. We ran some of it through a belt sander to make some of the copes and cuts and fits, and it was painful. At that point, as we're probably 3/4 of the way through making those rails, we sat down as a company and said, we need to do something different. We need to look at what our options are. And we had seen the Peacemaker software in the past. We had seen the EL squared machines. We got a hold of our local sales rep. We did an online meeting with Todd and his group, asked some questions. And one of the big things that really was positive for us was when I asked Todd some questions and said, hey, can we possibly get this feature added? He's like, sure, that's not a problem. So something as simple as a print button on a report made a big difference, because what it showed us here is they're willing to work with the customer instead of just saying, here's your machine. And we've actually done the same thing with design data, with SDS2 as far as features and options. Chris and his team have been great for us that we've brought some ideas to them, and they've been able to implement some and help us work around using some already in package features to where we could move forward. So we went through the process, built these rails manually, and then of course in the end we had some rails get added to the project. So if you jump to the next slide, you'll kind of see the modules. It kind of gives you an idea of what's going on with them when they all stack together. And you see some of that tracking down there across the bottom. And you can see the little white tags on the piece of the tube steel and piece of the plate. The frame itself is a seismic rated frame. So all those parts had to be just right to meet the seismic criteria. And then we have the process support material that was the infill. Very complex. We worked on the drawings for 1.5 years before we ever purchased material. And it got to be where our 3D model basically became the check of the design team's model. It started off in AutoCAD Inventor. It went to SolidWorks. We got it into SDS2 and fixed it, converted it back out, and they'd run it against their SolidWorks model and figure out where we had made the corrections to get all the geometry correct. So it was a big plus for us, because then we knew already when we go to production and we can track these parts If they have a change or they have a modification or a clarification comes through, we know exactly where it's at, what we need to do to stop it and either work around the issue or work with the issue. So it was a big, big plus for us that everything was integrated. So there you just see some barcode scans. We get our date time stamp on each of those parts. And when the inspectors would come in, they'd want to see these reports. Well, there it is. We can put it right out into an XML report file, hand it off to the customer, and satisfy their questions as far as that. So we would do the same thing with material tracking, with paint, with weld wire. We put our weld wire into inventory. We put our paint into inventory. So we knew what day, which welding operator, what time a roll of wire was pulled to be used on the project. Same thing with the paint. We had all the data on the paint, so we knew what day it was open, what day it was sprayed, what was left over. And we put all that into STRUMIS, and we used the inventory control for that, and had already pre-allocated those materials to the project. So on the next slide there, so up there where it says rail processing, I went back and grabbed all the timesheets and kind of put this together. So there's 438 pieces of pipe material. You see the saw cuts and how many miters, copes, miter to the left end, right end, the cope on each end, and how many there were reworked, because there was a lot of missed copes because of the timing on the ends of the parts. And one of the big pluses of EMI is you have a button in there that you can control what that offset is, if it's 0 or 180 based on your rail geometry. So we went through and here's actual cost of what it costs us to do it. And then we also ran the same number of the same original rails through the piecemaker. Well, it said, hey, you need 70 sticks of pipe, and went through and took some current time that we've seen material run through the machine and getting some parts. And we're not pushing the machine quite as hard as what Aaron had spoke about earlier, but we're getting good quality parts off of it for us. And I've done some cost analysis in there. So whereas originally in the material prep, for somewhere around $19,000, had we run it through the EMI machine, we would have been somewhere about $3,600, plus minus a little bit. From that, produce a 10-foot section of rail manually, it was about $66 a foot in labor, compared to if coming off the EMI machine down to around $14. So it's taken our rail production and it's allowed us to be more competitive, because we're not a miscellaneous shop on the front end doing strictly stairs and rails. Stairs and rails come with the structural projects. Now what we've done is we've had other projects come in. We're like, oh, we can use this machine and we can get these added features. So we've got into producing rails with internal venting, different the multi-bend corners where it's pre-notched, where you can form a 90 out of one piece of material instead of having two pieces of material. It's taken us less time as far as weld prep, weld cleanup. So we've kind of taken it all, and with the abilities that the EMI machine and piecemaker offer, looked at our rails differently. We get back to the toolbox from SDS2, and it's putting out great information right now. And when you learn the features of that screen that you're going to show, and you see what's on there, and you learn the translation to get it to piecemaker, it's a very simple process when it all comes together. Where STRUMIS comes into that is we nest one rail at a time as far as what we're going to cut. Well, we get the barcode tag of main member. We put that on the rail. We push it through so we know if we've cut 12 rails today, we know what those part numbers are. So we get the status update, because that's what we're tracking is the main member. We get the status update in STRUMIS. We know, once again, the time date stamp of when it was produced.
Very good. Good info. That's a pretty significant savings that you show there. So that's impressive. Very impressive.
It's helped us out. Helped us out a lot. And the nice part is, from the machine side, it doesn't care if it's carbon steel, if it's stainless, or if it's aluminum, because it has the capability of cutting those 3 different types of material with the same accuracy and precision each time.
Awesome. Let me, I'm going to switch over here then and share my screen. So we'll give you a bit of a rundown here on what this all kind of looks like within SDS2. So let me just share my screen here. Hopefully you guys see my SDS2 model up here. Looks like that model that Joe shared some screenshots of a little bit earlier. So he shared that with me just to kind of give you a little bit of idea here. So I mentioned the STRUMIS and the BSWX. Chris did inform me here on the back channel that I did speak incorrectly earlier. BSWX is not required for the barcoding. That is still possible doing the KISS files. It is required, however, for getting the status updates back into SDS2. So a little clarification there. So here's our model. Here's my STRUMIS export. Like I mentioned, I've modified under the Import-Export tab to go ahead and just group those together here. So when I run that, as I was saying, we've got our output path, file name. I could just check that on and just say, give me all the data, or, I can pick and choose, whether I want specific members, select by the details sheet, throw in my CNC info, attach my drawings, all that done through here. So pretty simple. It's going to create a BSWX file. It's going to have all the drawings exported at the same time, all the CNC exported at the same time for you. And then when we want to get to those status updates that Joe was discussing, we do have the production status set here now. In order for this to work, it pulls the information directly from the STRUMIS database. So you do have to set that up to connect to the STRUMIS database. I don't have that ability. What I will do here is pull up a couple screenshots. So can you see my screenshots here, Chris, or am I still on the model here?
You're still on the model.
Still on the model. Let me see if I can adjust that here and get my screenshots up then. So let's go here. I can go ahead and show you some of the status updates here then. So Joe, do you have any idea? Can you give us any idea what some of the status updates here are on what I have shown here then in this screenshot?
Sure. On this one here, David, so anything that's shown in the red color, those were in the fitting process. So the material was saw cut. It was at the fit stations. And then anything that was shown in pink is fit complete, QC check has been done, and it's in the welding staging area. Anything that's shown in orange, which would be the stair stringers, it would say welding complete. and then the cyan was fit complete, and those rails were welded to the matching connection components for the bolt-on or the weld-on feet or the shoes to go onto the material. And then ultimately, in the end, there's some diagonal bracing in there, which would have been purple, and that would have been completed parts ready for shipment.
Okay. I think hopefully you see the new screenshot here. So we've got another screenshot. We've got a lot of magenta. We throw some black in there now.
Yeah. So the black was delivered to site.
So
we'd
black
actually
is
delivered it to our customers at that point. Yeah.
So you must barcode even at site, like when it's unloaded then as well? You scan that barcode to get the update back on that, or?
We use the barcode feature that's on the bill of lading. So when we've loaded the truck, either one component to a truck that has the main member barcode, or we've put 150 beams on a truck, is it builds that barcode or that bill of lading out for us. We get a barcode generated up there in the top right-hand corner. So we can scan that barcode and say, trailer number 5 is ready. And then when it leaves, we can scan the barcode again. And we get a time date stamp of when it left our facility. And depending on how it's set up to receive the material, we can actually barcode it when it's offloaded at the customer site.
Okay.
All through the mobility.
Very good. Let me go back. So that's kind of a little bit quick overview, obviously, of the STRUMIS export, the status updates. Let me see if I can get my screen share correct here a little better on my SDS2 model. So I'm just going to switch screens there a little bit. Hopefully you should see my model here again. Now, just to give you an idea, again, the EMI export that we've developed, again, that's a toolbox item. You can go get that from our website on the SDS2 toolbox. Again, I've modified my import-export tab through in a section here for the EMI, so it's standing there on its own. Now, I will point out, a lot of companies, a lot of fabricators are looking at the EMI machines specifically for their handrails. That's great. Doesn't necessarily have to be for handrail. This is going to work for, other materials. That's tube, pipe. Right now, the export from SDS2 is working with both tube and pipe. So it can be, it can be a beam, it can be a column. It's more limited at this point to the machine limitations, what size of material can be run through that machine. So just kind of the way this works, I'm going to select a few items here in the model. So I've got a couple beams, a column, some handrail in there. And when I hit the EMI export, then this is actually going to give me a screen, and it kind of previews or shows me the output that I'm going to get within this screen. And if there are certain things about this that I want to modify even before it gets exported, I have the ability to come in here and lock that variable, make an adjustment here so that it then gets output with the values that I input. Generally speaking, I hope we get that right, and you aren't going to have to be doing that a bunch, but we do have the ability to get that done. And then you can see here with the member mark, so that's just for the one column. And then I can flip that over to my beam. You'll actually notice that it highlights the appropriate member in the model as I flip through that. We're getting that, and then the screen repopulates with the information for that particular member that I have selected. And you're going to notice, it goes through, it reads, detects every pipe, every HSS on that member, and that's the information we're going to see populated within here. When I do the export, it sends it out to the path that I have set here. produces an XML file, and that goes into the Peacemaker software then that runs the EMI machines. So fairly basic there, pretty straightforward. A couple things I will point out. You know, I know with the galvanizing, your vent holes, your drain holes, all that good stuff, that can be pretty cumbersome a lot of times. So EMI and their Peacemaker software, they do kind of have a rules-based, you know, stuff that you can set up to tell it how to create the vent holes in that. So we've thought about that as well and how to get that from SDS2 to EMI. What we've done is we use a custom property. So if I'm on one of my materials and I grab one of my materials and have a look at the material properties, you're going to see an internal venting strategy here. So this particular model, this project, Brion Hardin's kind of using must be probably some custom, older custom properties, so the screen might look a little different than what you're typically used to. But this internal venting strategy here, if we've got this set up and applied to this material, that matches that internal venting strategy in the Peacemaker software, it's going to go ahead and get those vents applied as is set up in the Peacemaker software. So that's kind of nice there. In order to make this easy to apply, you know, you may have just a little tip here with the handrail members. Generally, every material on those handrail members gets a usage description applied to it based on what it is, whether it's a mid-rail or a post or P-end. They do have these usage descriptions automatically applied to them. I could take that and I could use my status display. I could use, you know, the status select tool. So that is what this is this is a very similar interface to the status display, but I can use it for selection. So I can select materials when the material usage description matches that usage description for handrails. Notice it goes through the entire model, grabbed every mid-rail. So if I wanted to apply that venting strategy to all of them that I had selected there, then I can hit the material properties. I could put that in there, or maybe the venting strategy might just be called mid-rail in Peacemaker, whatever it is. We just need to coordinate so we get those to match and transferred over. So nice little tool there. A couple things to note there. I do have another model here that I'll pull up. I just wanted to use this model to show you how to actually get that internal venting strategy custom property in there if you're not seeing it. So what I'll do is I'm having to coordinate multiple screens here and manage multiple screens. So on my project settings, so I go out to my home screen, and in my project settings, I can go to my custom properties over here and activate custom properties. Now, we provide this out of the box, so we have this EMI custom property. I just have to make sure that I come in here. If this says available, I need to pick that, hit activate. This will turn to say active, so now I know it's active on this particular project. And then when I'm in the model, when I grab the material again and I look at the custom properties, this is what a lot of you might be seeing if you're using more out-of-the-box type custom properties, where we have the tree on the left and then we're separated out into different sections. So you're going to see a specific EMI leaf here on the left with that internal venting strategy that we can use then. So, you know, I could also run my status display. So I have a selection filter that uses status display. I could do the same thing I did previously with the status select, but this lets me be a little bit more precise with it. So I put my material usage description in there, and now when I just draw my selection box, so it's going to filter and grab only those materials within that box that have that specific usage description that I can apply properties or whatever it is that I need to do with it at that point. So that's kind of the SDS2 side of things a little bit. A couple tips there. Yeah, I mean, that's what we got for you guys today. You know, I just want to tell everybody thank you. So everybody that's attending here in the audience, appreciate everybody's time. And then Joe, Chris, Aaron, appreciate the work and the time that you guys put into this to present this to us. So, yeah, it's been great. And we're going to take some questions and answers at this point.
Okay, so we got a few questions that were coming in here as we went along. I'm going to do my best to read the question for everybody to hear, and then I will pass that on to the correct person, whether that's Chris with STRUMIS or Joe or Aaron there. So the first question that we have here is, I think, Aaron, you had mentioned some projects that EMI was used on there in your EMI introduction. So got some people interested in seeing those pictures of those projects. I don't know if you have that information on a website or different project examples, but that would be great if you had that on your website. Maybe, or if we could find a way to provide those to our attendees, that'd be great. Second question here, are there any machines in the shop? So this one would be a good question for Joe. Are there any machines in your shop that don't communicate with STRUMIS? And if so, how do you manage that in STRUMIS? Or did you maybe mute yourself there, Joe? I don't think we're hearing you. Okay, we'll maybe come back to those that maybe are specific to Joe. There are some questions here related to SDS2. So one of the questions is referring to the rails and how the rails are modeled in SDS2. So, you know, I know on the project there from Brion Hardin that we were showing those were done using the handrail member in SDS2. A lot of it was, you know, fully automated, but there are some limitations in that were in there also. So some of it was, you know, modeled with the rail and then manually adjusted afterwards that maybe made it graphical. And then there's related to that also is if the notches at the horizontals, like those mid rails, were being modeled, and the answer to that is yes. So the handrail member will automatically notch the mid rails, so that comes in there. Now, I do have a couple of the people, Aaron, if you're still with us, you may know, or I do have one of our developers here on the back channels that might be able to answer this. I believe in the XML, we're not necessarily communicating the notches in there. We're more communicating just the lengths, kind of overall lengths of the pipe, and then how they frame together at what angle and such, and what size of pipe and everything in the model. And then when that XML is imported into Peacemaker, Peacemaker is actually kind of calculating the notches on their end. So that's kind of what it's doing in the background. So technically, if you weren't modeling those notches in the model, you could still get that into Peacemaker nicely. So And then, Chris, this may be a question for you, I believe. So, so since we're doing the specific EMI export with that XML file, can those files be passed through STRUMIS similar to DSTV files and such?
Yeah, sorry, some technical issues there. Yeah, the process is you would send the XML through to EMI, and you use the standard STRUMIS BSWX format. It doesn't need to go straight through STRUMIS because the XML was developed for EMI with SDS2. So there's no need to send additional files through to EMI.
Okay. How about here's an interesting one about kind of related to barcodes. So you are doing barcoding that's built into STRUMIS. What about a QR code? Can you produce a QR code to use rather than a barcode?
Yeah, so the barcodes can be in any format pretty much. When we're using our barcodes, we only use the kind of 1D, 2D barcodes because that's the only requirement that we need. If anybody prefers to see a QR code, then we can change it to a QR code. Essentially, a QR code can contain a bigger data set, so different field names, whereas our barcoding it only needs an ID from our software. So we're not actually scanning the label itself, we're scanning the IDs in the background that STRUMIS has prepared. So if you'd like to see a QR code, then that's fine. We do have people that find QR codes are more consistent when it comes to scanning if there's damage, but it's not a requirement because the data behind it is just our own IDs. So the answer is yes, but the end result is still the same. It's still an ID that we need to communicate to the database.
Okay, good to know. Good info. So here's a question from a fabricator here with regards. So Aaron showed the example of the corner posts and kind of how EMI can produce the cut with the 3 posts kind of corners coming in together. So I think the EMI output is not doing that particular output yet. So it's something we can look at, improve for the future. And, if anybody's running into any other, runs into any other limitations or whatever, definitely get those to us here at SDS2 so we can make improvements on where we might see some limitations and such. So. Joe are you on now with your mic? Okay, perfect. So let's come back to some of those questions that were geared probably for you to best answer for us. So first one, are there any machines in your shop that don't communicate with STRUMIS? And then a second part to that is how do you manage that then if they don't connect to STRUMIS?
So the machines that yes, we do have some machines that are not connected to STRUMIS. So through that, we produce our standard cut list or cut plan, and then at the machine, we replicate that cut plan information as far as producing that nest and those parts. And then once those parts are produced, we go back into STRUMIS and we use Production Console to advance those parts forward. We're in the process of transitioning to the STRUMIS Vision update to where it has more of a dashboard feature. And we'll be using that same process to advance the material through and then also record the drop sizes of material at the machines to go back into inventory or be placed into inventory.
Okay, very good. And then here's one related to some of your cut lists that you were talking about earlier. How is that entered and how is it exported? So kind of in other words, are you manually entering that? Are you importing the files? is it sent directly to the machine, or does the operator have to enter it in? What does that kind of look like?
So we do both. We typically use the BSWX import, allows us to manage the project forward. We can bring in a KISS file, and with that, we can generate the barcode, we can generate the cut lists. For structural on the drill line and on the angle process, we use cut plan replication. We reproduce it at the operator station as far as the information that's given to us in the nest. For our plate, we export that out from STRUMIS to shop data systems, record the cut plan number back into STRUMIS, and then we use shop data as far as a control feature for the burning process on the plate machine. Once again, when that process is done or that plate is complete, we then use production console and move everything forward as far as status check on that. So that's how we manage those components.
Okay. Very good. So I'm just kind of going through the questions here. It looks like we answered most of the questions there. There is one that the final question is asking about, kind of some additional steps that the detailer might have to incorporate into their processes that vary from fabricator to fabricator. So as goes with the way the world works currently, typically the detailer is the one having to typically meet all the fabricators' requirements and all of that. So yeah, unfortunately, if there's some additional steps right now, you as the detailer may have to work with the fabricators to understand their requirements and how we're having to do all that stuff. So looks like we got all the questions here answered. Just again, thanks to everybody. I appreciate, the patience with some of our technical difficulties today. So that's great, and hope to see everybody on the next webinar here. So Chris, Joe, Aaron, thank you guys for helping out doing all this. Really appreciate it. And thanks to everybody for attending. Enjoy the rest of your day.
Thank you, David.